Hey all, welcome back to the lab. In this post, we're going to be talking about Advent of Code 2024 Day 6 and my solution in F#. So as a reminder, HAMY members do get full access to the full project files that I use to build and run these solutions, so you can just get clone and run it yourself. And in this post, we'll go over, all of the logic code at least, so you can copy and paste it from here as well. All right, so let's start off with Day 6, Part 1. So as always, the prompt's here, but I can't show it to you. So you can go there to read the full prompt, but we'll go over my summary. And so basically what we're given is a map. And the map has a few different things that can exist on it. So we've got this caret thing, which means this is where the guard is, which is facing up. We have this hash, which is the obstacle. And then we have this period, which means it's an empty space. And together, put it in a big grid, this makes a map. And basically, the rule is that the guard will move in a straight line. If it hits an obstacle, so it hits one of these guys, it's going to turn right 90 degrees and then continue on. But if it ends up off the map, then it's out of the map. And so the ask is, how many distinct positions will the guard visit before leaving the map? This is kind of one of those Pokemon gem things where, maybe in an ice gem, you get on the ice and you kind of slide forward to the rock, and then you got to figure out how to get to the next part or something. That's basically what we're simulating here. And so there's a few subproblems we have to solve. The first is moving this guard around. There's probably many ways to do it, but the simplest is probably just the imperative way, where you track the guard as a position and a direction, and then for each tick, you're going to see if we're in an infinite loop, so you don't crash your program. Check if you're at an obstacle, in which case you need to turn. Otherwise, you're just going to move forward in whatever direction it's in. So relatively simple, or just moving the guard around the grid. The next one is, how are we going to track all the positions maps, because we are trying to find the sum of these. You could just keep a visited log, which is a copy of the map with visited locations, and this would give you in data. Would cost only O of 1 to write, but to sum it is O of n. And I think if you were visualizing this might be the way you want to go, because it'll maybe make it easier to visualize. But if all we need to do is sum this, then we could just keep a visited log, which is just a set of tuples. And so that way the write is O of 1 and the sum is O of 1, because we can just do count. We also don't have to deal with any duplicates or anything. So this is probably the simpler one if you're not trying to visualize it. And so basically what we'll do is we'll just read the input, and as a map, we're going to generate the guard positions, and then we'll sum all the positions up. So here's the code, but I'm going to show you in my editor. Okay, so here we are in day 6. And fair warning that I've got quite a bit of code here, because I was trying to model the domain, which may be not necessary for something like this, but I wanted to just do it. And so basically I'm modeling some types in the domain, right? So we've got a position, which is just an XY coordinate. We've got a direction, up, down, left, and right. And then we've got a guard position, which is basically what is its current position and what direction is it going in. I could also name this I don't know, a vector or something like that, but we're probably being too specific with this naming, but it is what it is. And then we're saying what map items exist. And so we're saying a map or an item on the map can be an empty space, an obstacle, or a guard. And that's really the only options we have, so we use a discriminated union to show that. Finally, for the day 6 input, basically what I'm saying is when we read this map out, we want to have a full map containing all of the map items. So, what is the semantic meaning of the things on the map? And then what is the current guard position, because that's what we need to be iterating on. A few helpers that I built up to try and, again, model the domain is we're going to try to convert the string to the map item. And so, period goes to empty, hash goes to obstacle, caret goes to guard. And then if we don't have that, we're just raising. In general, I don't want to raise for things like this. Maybe I would return a map item option, but considering I know that it must be one of these or else I'm doing something stupid, I'm just going to fail hard here. I'm creating an isGuard helper to just match on the guard case. And that's basically everything we need to actually read the input here. And so we try to read the input, we get the file name, we get all the lines out, and then we create the guard map here. So we're just going over all the lines, we are iterating over them, and then we are splitting them into a character array, making each of those strings, because I like strings over chars, turning into a list, and then making this a list. So this is how we're getting a stringless list. And then what we're going to do is we're going to turn the stringless list into a typed map item list. And we're just doing that by iterating over each of these strings and turning them to string to map item, which we already talked about. And then we're getting the guard position by basically just mapping over everything, finding the one where we actually have is guard, I'm returning that as a sum xi, and then we choose this. So this will only return the one thing that is sum and not none, which only exists when we actually found the guard. And then we'll take the first item of that, and then we'll return that as the position. And then we just create where the guard is, guard position direction.up. I'd assumed that the guard could be in other positions, like not just facing up, but it seems like it can only start in up, so we don't have to parse that out. We can just assume that it's up. Then I return that, and so that's how we get the input itself. A few other helpers that I wrote is like get next direction. So given the direction, we know that it needs to go 90 degrees to the right, and so I'm just making this super explicit. So, if you're going up, you have to go right next, right to down, down to left, left to up. So that we just have a simple helper for this. And then also a helper for get next position. So given a current position and a current direction, we're just going to move you forward in that direction. Final helper, I think, is just get map item at position. I like these helper functions for these grid layouts because I don't like having to check for like null cases or like, are we out of bounds or anything. And so this helper basically just says, if you're out of bounds, we're going to say there's nothing. But if you are in bounds, we're going to grab the item at there. So it's just much easier and cleaner usually in the logic to do a conditional on. Okay, so here is the core of the code. But after talking about all these helpers, let's go look at the actual solver. And so solve part 1, give it the file name. We read the input here, which gives us our day 6 input, which is structured. And then we're just going to get the visited position set by calling calculate all guard positions, pass in the guard map, and pass in the guard position. And so this is where all the calculations are happening. So basically we're going to pull out the current position, current direction as immutable, and this is going to be like our pointer to understand where the current guard is at. Then we're going to create in a set of places we visited. We'll start it off with the current position, and then we're going to have this variable for keep iterating because as far as I can tell, we don't have an early break for loops in F#, and so we basically have to do this like thing where we keep a variable to tell if we can break out or not. And so we're going to pull out the next position and the next map item so that we can see like what are we about to iterate into. And we'll use this to determine our iteration logic. And so if the next map item is none, this means that we're like off the map and we need to stop iterating because there's nowhere to iterate after you get off the map. And so we'll just set keep iterating to false, which will get us out of this loop next, and then we'll return this. But if we do have an item, then it means, all right, the next position actually is on the map, so we need to do something about it. And so we're like, well, what is this item? If it's a guard or an empty string, because the guard won't be there anymore, then what we need to do is actually move forward. So we just like, all right, current position is the next position, say that we have visited this new position now, and then we'll iterate again to see what the next item is. But if it's an obstacle, then this means that actually we can't go forward. And so what we actually need to do is get a new direction and point our guy there. We're like turning him, I guess. And then we'll iterate again, which will do the whole logic again. So ideally, we loop through. And then once we're out of that map, we stop iterating and we get down here and return the visited position set. So this seems to work. I got my 2 stars for this. So that is part 1. Yeah, a lot of code, but most of it is just munging the input into something that's like, something a little bit more semantically meaningful. Okay, so on to day 6, part 2. So we're given the same input as above, but the ask here is to find all positions where a new obstacle could be placed that would lead to an infinite loop. And then we want to like count those basically. So all places on the map we could put an obstacle that would lead to the guard entering an infinite loop. But you can't place it at the guard start position because he's like there, so it would be like on top of him. So that is the given task. So we have a few subproblems here. One is like, how do we determine if we are in an infinite loop? And basically what we can do is we can keep track of all visited locations, but locations isn't enough. We also need to include direction. And so the reason location isn't enough is because, you can cross over your path, like you can go up here and then back and down. That doesn't mean you visited there. However, given the rules of the guard's movement, if we have the position and the direction, then we do know that he's going to end up in the same place he was before because he can only go straight and to the right. And so if we ever do see the exact same position and direction, then we're in a loop and we can, return that. But if instead we leave the map before we find this, then we know that there is no loop in this guy's path. And then how do we figure out if we are in an infinite loop, or if an infinite loop could be created with the obstacle at a given position? And so basically at every position of this, you can just put an obstacle down and check if they're there. Note there is some issues with how I wrote this at the beginning. I say at every position of the guard, check this, but this is actually not going to get you the right answer, which we'll talk about in a second. And so my brute force solution is basically to iterate over all these positions and at each see if there would be a loop, and then we'll just return all loops. And so I initially started with like brute force being like, oh, we'll just put an obstacle at every position where the guard might go, because this will be like all positions the guard could be at, and so where the obstacles actually make sense. Intuitively, this made sense to me, and I assume this would be more efficient because we wouldn't need to try every single position on the map. However, I could never get the right answer with this, and thinking back on why this was, it's actually incorrect because the initial path of the guard may have changed based on where the obstacle was, and so just assuming that the initial path of it is valid the whole way through is actually incorrect, because an obstacle, if it was placed at time 0, might have changed the path's guard, and so now the guard would never have been on that path to start with. And so actually the true brute force way is a better way to go about this, where you try every position on the map regardless of where the guard was walking in the first place. So that's what we ended up with. And so here is all the code. Look at the editor, and let's just jump down to the entry point for this. So here is solve part 2. We read our input, same read input as we had earlier. This is day 6 input. And then what we're going to do is we're going to find all guard loop positions brute force. We pass in the map in the initial guard position. We dedupe, remove the initial guard position if it's there, and then we return the count. All right, so to brute force this, first we're creating a list of all obstacle positions. Probably should have been a set or something, but it's all right. And then we're just looping through the entire map. We pull out the current position that we're at, or we're thinking about putting an obstacle at, and then we get the map item that is at our current position, and then we're going to match on this. So if the current position is none, then this means we've done something horribly wrong, and we can't continue, so we're just raising here. But if we do have an item, then we're going to match on this item. And if it's a guard or obstacle, then we know that like we cannot put an obstacle here, so we don't even bother, we just pass and go on to the next loop. But if it's an empty space, then it's like, okay, we can put an obstacle here. And so what we're going to do is we're going to call this helper function to basically create a new map with one coordinate changed, and we're saying, hey, put an obstacle at this position using this map as a basis. And then what we're going to do is we're going to call this helper, is this map a loop, passing in the new map and the guard's position, which will run through basically the logic that we had earlier with the few modifications. And then if this is a loop, then we're just going to add our current position there, because you know, if we put an obstacle there, it is a loop. Okay, helpers, change map coordinate. This one just takes in the map, the position to change, and the item. And basically what we're doing is we're looping over this as indexed. We map the y index to the row, and then we map over this with index, so we have xi. And then basically if we ever find that the current position is the position to change, then we would just replace it with the item that we want to change. Otherwise, we just replace it with the item that was already there. And so this is how we are, you know, cloning this thing with one thing changed. I feel like there's a better way to do this, but this is what I came up with. So, you know, let me know if you have a better way to do this kind of thing. All right, so that is how we changed the map. And so now we've got that new map with the obstacle there. And now let's look at how we're looking for a loop. And so this is going to look very similar to my previous one where we have the guard simulating through the map. But now we're just keeping track of like whether we're in a loop or not, right? So we pull out the current position, the current direction. We have our visited position set, which is position and direction. We have our keep iterating, and then we just have an is loop, which we're going to start off as false. So basically, we just check like, hey, have we been here before? If we have, then we're going to say we are in a loop, and we're going to set keep iterating to false. And then we're going to add our current position, current direction here. Really, this should be an early return, but again, I really don't know how to early return out of a loop. So it's a little wasteful, but you know, going with it. Then we're pulling out the next position, the next map item. Again, we say if the next map item is none, then keep iterating is false. If we do have an item, then we're going to match the item here. So if we have a guard or empty, then it means, yeah, we can go there. And so we'll just, you know, move forward. Otherwise, if we're an obstacle, then we need to set a new direction, and then we do the current direction here. And then at the end of all this, after we've, you know, ideally removed ourselves either because we're off the map or because we've already been here before, we're going to return this loop. So we do that, and then this takes my computer like, I don't know, 2.7 minutes. Yeah, my debug code takes like 29 milliseconds on, you know, the debug input, which is really small. 6.1 takes 19 milliseconds. And then we got to wait on, you know, the full 6.2 input. Yeah, about 2 minutes and 59 seconds. So, you know, not the fastest thing, but It gets done eventually. Yeah, that's it for day 6. If you like this post, you might also like my other AOC 2024 solutions here. All doing an F sharp this year so far. So that's it for this video. Thanks for watching, and I'll see you in the next one.